On to section C, find the inverse. So remember, f of x is the same thing as y. So this means the same thing. Y equals negative 2x plus 1. So for finding the inverse, we switch the x and y. So I'm going to switch it to be x equals negative 2y plus 1. Okay, we can't leave the answer like that because whenever we have the equation for our graph, we have y solved. We never just have x equals, it's always y equals. So I need to subtract 1 from both sides. So I have x minus 1 equals negative 2y, and then divide by negative 2. So this, my inverse, f of inverse of x equals x minus 1 over negative 2. Next one. So again, this is the same thing as y equals. So I'm going to first switch my x and y. So this will be x equals 5y to the third plus 7. Okay, reverse PEMDAS to solve for y. I'm going to first subtract 7. And then that will give me x. Let me just draw a barrier here. So that will give me x minus 7 equals 5y to the third. Now I'm going to divide by 5 because we can't just take the third root here. We need y alone. So I divide by 5 on both sides to have x minus 7 over 5 equals y to the third. And now I take the cubed root of the whole thing. That cancels out my exponent, and I can say my f of inverse is third root x minus 7 divided by 5. Okay, so this radical goes all the way down for the whole fraction. All right, number 14. Again, I'm going to switch my x and y. So this will be x equals 1/3 y minus 4. Reverse PEMDAS, I'm going to add 4 to both sides. So I have x plus 4 equals 1/3 y. Okay, so now we have a scary fraction. So with fractions, to get rid of it on this side, we're going to multiply by the reciprocal. So the reciprocal of this is 3 over 1, or just the whole number 3 is the same thing. So I'm going to multiply by 3 over 1 and multiply this side by 3, which is the same. Okay, so if I were to multiply straight across, I'll have 3 over 3, which is 1, which is why the reciprocal cancels it. And I'm going to distribute this 3 to each term here. So my inverse is equal to 3x plus 12. Next, last one for just finding the inverse. We have, again, y equals, so I'm switching the x and y, and then solving for y. So I'll subtract 5. So this will be x minus 5 equals negative 5y. And now divide by 5. Divide by negative 5. Here it cancels. So that is our inverse. F of inverse equals x minus 5 over negative 5. Okay, so this last two questions here, or two problems, says verify and prove. So that means the same thing to verify and prove. So these are equal in meaning. So to verify, what we have to remember is it's the composition of each other. So we have to find f of g of x, and we have to check the g of f of x. And what we're trying to find is that when we simplify it, it will come out to be just x. So here, it will be f of 5th root negative x over 2. And so I look at my f function. This is negative 2, leave a space, to the 5th. Okay, so this x is going to be replaced with this function. So I'm going to write in 5th root negative x over 2. And now we reduce. So the 5th root raised to the 5th, that cancels out the whole radical. So this is equal to negative 2 times negative x over 2. Actually, I'm going to put that in parentheses. So when we multiply here, remember this is like 2 over 1, and you multiply straight across. So this would be 2x over 2, and the 2's cancel, so we have just x. Right, so that was our f of g of x. So far we have just x. Now we have to see if the other one will come out to be just x. So I'm going to write it as g of negative 2x to the 5th. And now I'm going to write out my g function, but leave a space for x. So that will be the 5th root of negative, leave a space for x, over 2. So this will be negative 2x to the 5th. So be careful with those signs, because this x is negative and our f of x is negative. So these negatives are going to cancel out. So I have the 5th root of 2x to the 5th over 2. 2 over 2 can cancel. So we have the 5th root of x to the 5th. And now this radical can cancel with the exponent. And that equals just x. So yes, they are inverses. Okay, the next one, prove. So same thing, we're going to prove that these two are inverses. So we have f of g of x, and we have g of f of x. So that part will not be given on the test. You have to remember to set that up as compositions of each other. So this is f of 2x minus 8. And just to go over here, this will be g of 1/2 x plus 4. Okay, so to do this side first, I'm plugging this in where I see x. So this will be 1/2, leave a blank for space for x, plus 4. 1/2 x, I left the space, plus 4. Now I'm going to put this in for x. So I have 2x minus 8. Okay, so if I were to multiply this through, it would be 2x minus 8 over 2. So that would we would just divide 2 out of both terms. So we'll write that out. 2x minus 8 divided by 2 plus 4. So 2, this would only work out if this number can go into both terms. And it can. So 2 can go into 2 and 2 can go into 8. So here we will have x minus 4, and then we have this plus 4. Minus 4 plus 4 cancels out, and it just equals x. Okay, so then on this side, we have g of 1/2 x plus 4. So I'm going to plug this in wherever I see x and g. So this will be 2. I leave a space for x minus 8. And I'm going to fill this into the space. So it's 1/2 x plus 4. Now I just distribute the 2 into here. 2 halves will be 1. X plus 8. 2 times 4 is 8. And then minus 8. Plus 8 minus 8 cancels. And we are left with just x.